Before we get started taking official notes on the next section, I want to ask you a few questions. I want you to think about a rectangle. If I were to tell you that the area of a rectangle was, we'll say, 30 square feet, and if I were to tell you that the length of that rectangle was 5, what would you say the width is? Hopefully your answer was 6. Okay, what if I changed my numbers? So this time I'm going to say that the area is 55, and this time I'm going to tell you that the length is 11. How would you figure out what the width is? Did you get 5? Alright, I'm going to change it up one more time. This time I'm going to tell you that the area is 75. Your length is 25. What's your width? I hope everybody got 3. So here's my question. This is clearly our formula for area equals length times width. Every time, did you really plug it into the formula? Did you plug in 30 for area, and did you plug in 5 for your length, and W for your width? And then did you use inverse operations to solve to get 6 is equal to W? Did you do that for every problem? I doubt it. I think it's much more likely that what you started to do was that you saw a pattern. Each time I gave you the area, you could divide your area by your length and get your width. What you did is you realized that each time I was asking you a question, I was asking you for the width. What you were doing without even realizing it is you were rewriting the equation or the formula that you're all so comfortable with to isolate the W. What you were doing is you were using what you already knew. If we know area is equal to length times width, how could I isolate the W? Well, I can divide both sides by L, because that's my inverse operation. So what you were really doing without even realizing it was taking your area divided by your length, okay, to find your width, and you were rewriting that formula. Alright, we're going to get started with our official notes now. Okay, we're looking at Chapter 3, Section 8 on rewriting formulas and equations. The first example we're looking at is for the area of a parallelogram or a rhombus. So I have a picture here. Just a quick reminder, the height of a rhombus is really the drop height, and the base of a rhombus goes along the bottom. This example asks us to rewrite this formula for B. So B is what they want us to get by itself. Area is equal to base times height. If I'm trying to isolate the B, the question I have to ask myself is what's on the same side of the equation as the B, and what do I need to get rid of? I need to get rid of the H, because if I can get rid of the H, then the B will be by itself. I know that B is right next to H, therefore I'm multiplying those two things together. The inverse of multiplying things is to divide them. So if I divide this side by H, H over H would give me 1, or it would simply drop out. But I have to do the same thing on the left side that I do to the right. When I look at my rewritten equation, I have area divided by my height will give me the length of my base. Let's take example 2. We have the perimeter formula for a rectangle. Perimeter is equal to 2L plus 2W. They're asking us to rewrite for L. So P is equal to 2L plus 2W. This problem is going to be a little bit more complex because I have more things going on. So I'm just going to put my circle around my L for my length. I need to eliminate my addition and subtraction, and then I need to eliminate my division. So the first thing I'm going to do is get rid of that 2w. I'm going to subtract that from both sides. P minus 2w, again I can't simplify those, they're not like terms, is equal to 2l. My formula is almost rewritten to get the l by itself. Again, the only thing left with my l is the 2, so I'm going to divide both sides by 2. And when I do that, let me extend this page. When I do that, I will have P minus 2w all over 2 is equal to L. I've just rewritten my equation for L. Let's look at a couple other examples. I'm asking you now to take this equation, ax plus b equals c, and to rewrite for x. So what I'm going to do is I'm going to pull a similar example to this, but just with some numbers to help us through this problem. If I gave you 2x plus, we'll say 5, is equal to 11. What I've done is I just plugged in a value for a, for b, and for c. This is what we already know. Everybody here would tell me that I should subtract 5 from both sides as a first step. I would be left with 2x is equal to 6. And remember, that 6 came from subtracting these two. And then you would divide both sides by 2, because you're trying to eliminate the coefficient. I would get x is equal to 3. I don't think there's going to be a lot of debate about that. Let's go back to our original problem. I'm asking you to rewrite ax plus b equals c. And essentially I'm asking you to do the same thing. I'm asking you to isolate the x. This problem's only harder because I don't have numbers in here for a, b, and c. But I'm going to follow the same steps. Just like on the left-hand side where I subtracted 5 first, on the right-hand side I would subtract b from both sides. B minus b would give me 0. I'm left with ax is equal to c minus b. Again, on the right-hand side over here, left-hand side, I was able to subtract 11 minus 5. For my actual problem, I can't because they're not like terms. I still want to isolate the x. I'm going to divide both sides by a, because I know that a over a will give me 1, just like 2 over 2 gave me 1. It leaves me with x is equal to c minus b all over a. Alright, the last two examples we're going to look at are very similar to each other. In both instances, I have something given to me in the format where I have a coefficient of times x plus a coefficient times y is equal to 8, and I'm asking to rewrite for y. Same thing down here for example 3. You're going to be doing some more practice on problems just like this. So if you haven't been writing these down, please write these two examples down. So I've got 3x plus 2y is equal to 8. Again, I'm trying to rewrite for y, so this is my focus. Maybe I'll put another circle in there to make sure that we keep our eye on the right variable to rewrite for. Okay, let's go back to our inverse operations. We know we have to get rid of the 3x and the 2. We're going to start by subtracting 3x from both sides. 2y is equal to 8 minus 3x. Again, I'm still trying to rewrite for that y. So what I need to get rid of is the 2. The inverse of multiplying by 2 is to divide both sides by 2. And I'm going to get y is equal to 8 minus 3x all over 2. This can be simplified further. At this point, that's not going to be my focus. We will come back to that later. But for now, can you isolate the y? The third and final example, we're going to do the same thing, only with different numbers. 5x plus 4y is equal to 20. Again, we are trying to isolate y. Let's bring another circle down. So I need to eliminate the 5x and the 4. Start by subtracting the x term. 4y is equal to 20 minus 5x. I'm going to divide both sides by 4 because I'm trying to solve for the y. I will get y equals 20 minus 5x all over 4. Again, it can be simplified further, but this, for now, would be good enough. This is what we're trying to do. Can you simplify and isolate y?